So I was talking before about focal length, and one of the things that focal length does is not only magnification, but also it helps change. Now this is tricky to say properly. Focal length gives us the perception of perspective, and what I mean by that is that if you use a very wide-angle lens, for example, and get very close to a subject. Now, if you imagine a wide-angle lens, that means you're getting a lot of the scene, into that one image, and then you get very close to a particular person or object. Then what you are doing is you're sort of distorting the edges. You're changing the perspective of that person. And in fact, using a wide-angle lens is a very popular way of sort of distorting people, or distorting, especially photos of dogs. People love to take really wide angles and get really close to them, so their noses look huge and their rear end looks really small comparatively. It makes them look sort of have different proportions, but that's what these wide angle lenses can do, is that you are altering the perspective by allowing, with a wide angle lens, allowing you to get closer to a subject and therefore get more of that subject from that distance within it. Now, on a 35 millimeter film camera, or even a digital SLR, which are typically about 35 millimeters in size in terms of the sensor size, a 50 millimeter lens is considered a normal lens. And what that means is that it just has a normal perspective. There's nothing distorted about it. It's not abnormally focused in, or rather zoomed in, for example, and you get this, as an example, this photo on the left side of my brother, just sort of a normal, average focal length, a normal amount of angle of view from that particular image. And if you put a 50 millimeter lens on your SLR camera, on most SLRs, as you look through, if you open your left eye and you look through the camera with your right eye, it actually looks to be sort of the same. It looks like you're looking through the same thing, versus putting on a ridiculous lens like this, for example. It's obvious that you are way zoomed in on one lens versus the other. Now, on the right, this actually is much less of a focal length. It's 16 millimeters. And as I said, remember, when you have a lower focal length, you have a wider angle, so you can get more of something in the photo. Now, perspective is actually a tricky thing, and I'm going to have to spend a little bit of time talking about it, but it's only tricky in the sense that the way you consider the relationship that most of you probably have in your mind between focal length and perspective is actually somewhat different than how you should be thinking of it, if that makes sense. So, in other words, yes, I'm telling you that you are doing it wrong, or you're thinking of it incorrectly. So, to say that focal length has a direct correlation with perspective isn't correct, strictly speaking. Now, what is correct is your change in distance to a subject. That is what is going to change the perspective of it. And so, when you are taking a photo, so for example, this photo on the upper left-hand corner. So just to give you an example, there's 4 photos here. We're going to go through them one at a time, and they start in the upper left-hand corner. This is 1, this is 2, upper right-hand corner, 3, and 4. So this first one in the upper left-hand corner, this is just a photo taken with a 33 millimeter lens. So it's not super wide, it's just sort of a wide-angle lens. Of a table and a salt and pepper shaker. So you can just get an idea of what we're dealing with this image number 1. That's all we're looking at right now. Now, let's say that we took a crop. So we brought this image number 1 into Photoshop, for example, and actually cropped the image out. And we specifically cropped the area in the red box right here. And then we blew it up and made it the same size as image 1. Okay, so we basically just cropped and resized to make it the same size. We then get this image number 2, and if you just note the way that the salt and pepper shakers look in this image, you notice that it doesn't really look all that different. It's obviously, we just cut it out of that image, we cut the center out and zoomed in, and then that's what we see. Now let's say that we take this 33 millimeter lens off of our camera and replace it with an 80 millimeter lens. Okay, so we've taken off this wide angle lens and we've put a longer lens on it, and we take a photo again. Now the result of that is image number 3. Now I'm going to ask you to try to compare the way image 2 and image 3 look. And if you look very closely, I mean, there's some minor differences like the color and that sort of stuff, but that's not really what we're talking about. We're talking about the perspective here. And you'll notice that the perspective appears to be the same from both. And this is exactly what I was telling you before, where you may have this perception in your mind that a wider angle changes your view of perspective within the scene, but that's not really what's happening, is that as you use a longer lens or as you zoom in, you're not changing your perspective, you're just taking a smaller and smaller portion of that scene and basically blowing it up, so to speak. You're basically magnifying the center of that scene different amounts. So the higher your focal length, the more you're magnifying, if that makes sense. So you can think of it almost like a telescope, or you know, like very much like we use the word wide angle in telephoto. That's sort of where you can think of this is coming from. Now, let's say that we removed that 80 millimeter lens, we put that 33 millimeter lens back on the camera, and we moved the camera forward all the way very close to the salt and pepper shaker. Then we took another photo. That is this photo. Now this is probably what you were thinking of when we're talking about using a wide angle lens to distort the perspective. And that's precisely what's happening, is that because you are now closer to these objects, your perspective of them has changed. And so by using a wide angle lens, even though we have sort of the same amount within the frame, because our perspective of it has changed, it alters its appearance. It looks different. It looks more exaggerated, for example. So using a longer lens will actually compress its perspective, as you can see here. Using a wider angle lens, and if you get closer to it, will actually make it look farther. Now those of you that are familiar with video might actually be familiar with what's called the Hitchcock effect, or I think it might also have another name of the Dolly effect. And what this is this idea of people using a zoom lens, and let's say you are relatively close to a subject, or relatively far, but we're just going to use close for an example, and have a certain amount within the frame visible in your viewfinder. Then as you zoom in to that subject, you take steps back. And you're doing this at the sort of same speed, so that as you step back, you are zooming in at the same rate, if that makes sense, so that as you move back, you are compressing the perspective. You are making the background become flatter against the subject that you are trying to take a photo of. And this was popularized, I believe, by Alfred Hitchcock, and that's why they call it the Hitchcock effect. But if we take a look at this video that I have of a movie called Goodfellas, if you've seen it, they actually do this exact thing. So pay attention very closely to the background as these guys are talking in the scene, and you'll notice that very slowly it seems to be changing the way that it looks. Oops, where'd it go? All right. Okay, it closed. Hold on. Let me try this one more time. Okay, so here, and just to show you an example, so this is before. So if you take a look, the background looks fairly well separated from the foreground. The perspective is not very compressed. We have very wide range, this great sort of depth that exists here in this perspective. But if I go near to the end, you can see the difference in perspective. So that's the end where now the background looks very, very close. So the perspective has been compressed versus the very beginning where it's separated. And by doing it quickly, you can see that we retain approximately the same amount of foreground objects in the image, but we are just changing the perspective by moving and by zooming in at the same time. Now, this compressed perspective can actually lead to some pretty neat things. And I'm going to show you this photo that actually that I took this summer in my hometown of El Paso, Texas. And it's not that impressive of a photo. There's a lot of stuff in it, as you can see. But when I took this photo and knowing where some of these locations are in El Paso, I realized that this would actually be a great way to demonstrate to you how compressed of a perspective this is. So to give you an idea, I used a very long lens. I used the 420 millimeter lens on my camera and was perched basically atop a mountain and took photos down the sort of main street called Mesa Street that's visible here. And if we take a look, so I just want to show you now on Google Earth sort of the distance that's covered between the foreground and the background subjects. All right, let's see. I have here on Google Earth. So this pin right here, that's where I took the photo. I was sort of at the bottom of this almost cul-de-sac area, and I was taking a photo in this sort of general northwest, or rather west-northwest direction. So if I zoom out and zoom out and zoom out and zoom out, all right, so this is going to take a little while. Let's see, I'll do this more quickly. All right, so now we are at basically the block level, and now you'll notice that there are a few houses over here. And in fact, it's these houses that you notice at the bottom of this particular image. So the roofs here, those are those houses about a block away. Okay, all right, yeah, I'm hearing some wows, but save them, because this is about to get a lot more mind-blowing. Oh, all right, so these houses right here at the bottom. All right, including one with a nice little sunroof of some kind. Okay, so going back here, now I want to show you, as I zoom out, this down here, this is the beginning of Mesa. Now, hold on, I got to go up a little bit. All right, so if we take a look here, you'll notice that we see U-Haul and Arby's, Discount Tire, that sort of thing. Okay, now I have to actually try to find this over here. That is, oh no, too far. Okay, that's the high school. That is over in this area. So Arby's is right here. This is, the U-Haul is right around here somewhere. And just to give you a reference, I'm going to zoom out again so you can see where's my, all right, so there's my where I took the photo there. Is there a scale on here? Well, I'll show you a scale later. Basically, you'll notice that there is a region where Mesa goes uphill. And in this area right here, this is actually my high school. And you can see that in the photo over here. That's where this region is here. Okay, so I'm just going to keep it at this zoom level, and we'll keep going west, basically. Now you see, if you look a little bit farther, all right, so there's a Circle K, Golden Corral over here. We see there's a bridge up here. Now this bridge right here, this is I-10. It's the major highway that goes through western El Paso. So I'm going to keep going west here. This is I-10 right here. The Golden Corral was right over here. All right, so just to keep going. Oh, where's my image? So now you can see that it gets sort of green, and this is what's called the valley, because El Paso is very mountainous, and this is the valley region. Now, you see that it's very long and straight before a left turn over here, and I don't know if you can see it, but right here there's a Circle K, very, very far gas station. So, all right, let's see if we can find that. So we keep going. You notice it starts getting green here, still going straight. Here is the turn, and the Circle K is approximately here. Now, if you were to load this on your own computers and actually I can do a distance check myself from here, but you'll notice that it is an extremely long distance from where I took the photo. And this is just a really extreme example of how much we can compress, the perspective. Okay, so I'm going to use the ruler and take it from, now let's see, where was that? So this was I-10. I'll take it from about here, and we'll measure how far of a distance it was. Oh, no. Oh, come on. Why is this so hard? All right, here we go. So in terms of straight distance from the very bottom of the photograph, which were houses right over here, to the very end, that farthest Circle K is about 5.5 to 6 miles. So you can get a huge range of perspective, or a huge compression of perspective, when you are actually using a very, very long telephoto. Now, if you were to ever visit El Paso and drive down Mesa, you would actually have quite a long journey. It would take you quite a long while down there. And then I think you would truly begin to appreciate, beyond what I can show you on Google Earth, how much this actually compresses the perspective. Now, on the other end of the focal length range is this idea of wide angle. So we can use wide angle to really alter, oh, come on, to really alter how different something can look. So whereas we can really compress the perspective with a long focal length, we can, oh boy, I can't advance in slides. I am just having so many tech problems right now. Oh, here we go. Okay. Oh, it shows on this screen, but not on this screen. Okay, so I will talk about it as if it were up on the screen, but basically you will see two images. On the left, oh God, please hold. Almost. I'm almost to a break point. Okay, so now we're good. Okay, so here we see two images. On the left, there's an image of a laptop, and on the right, there's an image of a room. And these are both the sort of images that you would expect to see with very wide angle images, because you would then get a lot of an image in, or a lot of something in on your scene. And usually you can use that to exaggerate lines if you want to exaggerate a lot of lines in your particular image. So for example, to exaggerate the lines within this room, or to exaggerate even the size of the room, for example, you would use a wide angle lens. And now, one of the things to watch out for, though, is the distortion that happens when you are taking a photo with a wide angle lens. So as you can see, this does look somewhat distorted. Well, I can tell you that the laptop is actually square at the corner. It's not sort of angled at all like this. But and the same thing will happen if you take a photo of a person with a wide angle lens. You can distort their faces and make them look a little silly, and they may not like that very much. Like my sister right now is actually texting me like crazy because she doesn't know that I'm in class, and so she would be really bothered right now if she knew that I had this picture up of her, even though this picture is now 5 years old of her. But using wide angle lenses, you have to be very, very careful with lines. You have to try to make lines perpendicular. So in other words, by taking this photo, I had to take this photo with the camera pretty much level to the ground. If it was at an angle, then the lines wouldn't look so straight in the back. They would sort of diverge or converge in some way, and it just wouldn't look natural, very much like is happening over here. So you have to be very careful with the perspective on a wide angle lens, and be sure that you are able to get all of these lines perfectly straight, and to try to get them to be at 90-degree angles. It's very much a fun exercise for you to have to do. Okay, so let's take a 5-minute break. When we come back, we'll continue talking about optics.